Good afternoon and welcome to Associated University, a group that is designed to provide supply chain management professionals with access to information on practical solutions concerning the industry's current hot topics. Today we will be discussing some of the reasons to undertake a network optimization project, explain the process, and demonstrate the benefits of network optimization through a few real-life case studies. Your presenter today is Wayne Lewis. Wayne currently serves as the Senior Director of Global Consulting and Engineering at Peach State Integrated Technologies. With over 20 years of experience, Wayne leads Peach State's consulting group responsible for network optimization, distribution center design, and operational excellence projects. Since joining the company, he has successfully completed numerous supply chain projects for a variety of clients. And now I will pass it over to Wayne to get us started.
Thank you, Sherry, and welcome everyone to our webinar on optimizing your distribution network. Here's a list of some of the topics that we're going to cover today and explore. We're going to talk a little bit about the what is distribution network optimization, and what types of questions does building a distribution network model help you answer. We're going to talk about the why. Why would you want to invest the energy and the effort and the resources in evaluating your network? What sort of business issues or problems might you be facing that would warrant an evaluation of your network? And then we'll talk a little bit about the process, or the how. How do you build a network optimization? What is the process? What is a methodology that you can follow? What are the key inputs and outputs that would be required to build a network model? So that's what we're going to cover today. And then we'll spend some time at the end, hopefully the majority of our time, really looking at the application of these concepts and principles with a couple of case studies and see how we've got results and benefits in the context of some real live customer engagements. So regardless of whether you're the senior supply chain executive or you're the warehouse manager or you're in customer service, whatever your role is, the bottom line is that all of us in the supply chain are really focused on providing value to our customers, helping our companies be profitable, and being competitive. We're asking ourselves questions like, what can we do to improve our service and be at the same level of service as our competitors? How can we take costs out of the supply chain? How can we improve our profitability? And how can we be better at serving our customers? How can we be more responsive? How can we improve our cycle times and our fill rates? Those are the types of questions that we're trying to answer, and we're going to show today that building a model of your network can help you evaluate where you are today and alternatives and solutions that will improve your overall supply chain performance. So the overall thrust of today's webinar is really to talk about, again, distribution network modeling, and we believe that you can identify that great balance between cost and service by building a robust network model using optimization software, following a methodology, using tools and techniques to help you answer and evaluate various alternatives to improve your performance. So at a very high level, what is distribution network optimization? And I would say at the very high level, network optimization is really focused on evaluating all of the logistics costs and the trade-offs of those various costs to meet your service level expectations. It's not just about minimizing transportation, it's not just about reducing facility costs, but it's really looking at all the costs that are involved in your logistics and trying to find the bottom of that curve where the overall costs are lowest within the expectations of your service to your customers. So as you can see on this graph here, in general, as you improve or increase your service requirements, you're adding additional DCs or nodes to your network, you're getting closer to your customers. Your transportation costs typically are going to come down, but that's going to be offset by increases in facility cost, increase in inventory costs. So again, the goal of optimization and building a model is to find the overall lowest cost of all of those components blended together. So let's talk a little bit about the why. Why would you invest the effort and energy to evaluate your network and to build a model? So number one is to identify supply chain inefficiencies. The optimization tools and software packages that are out there on the market are very good at providing visualization, both from a map and a flow perspective, so you can see how your supply chain has operated historically. They also provide great details around some of the cost and flows, and it helps you identify where your supply chain today may not be performing as you would like. You may need to reassign customers from one DC to another. It can show you when you have inventory placement issues. So the network model can be a great analytical tool to help you identify those inefficiencies. Obviously, the second one is to help you reduce overall supply chain costs. So by building a network model, you can quantify what your cost is today and then compare that to alternative network structures and then build a business case for what's the incremental value of moving from the supply chain of today to the supply chain of tomorrow. Thirdly, there's a lot of competitive pressure today to improve service, and a model can help you understand what is that incremental cost to improve your service. So if you have a mandate or a desire to move to servicing, let's say, 85% of your customers within 2 days, and currently you're servicing those same customers at maybe 50% within 2 days, a network model can help you quantify what will it cost you to get to those desired service levels. Fourthly, a model can help you evaluate changes in your supply chain conditions. Often we run across customers who have gone through acquisitions and they've incorporated additional DCs into their network, and they're trying to understand, should they keep those DCs, should they consolidate, should they move the DCs, and by building a model you can quantify those things before you actually go out and start opening and closing facilities. The modeling efforts will also help you evaluate the impact of servicing new business. We'll talk about this in one of the case studies, but if you're looking at penetrating new regions or new markets, you can build a model of what it would cost you to service it with today's infrastructure network, and then again compare that to an alternative network to maybe service a market that you're not currently in and maybe is far away from your existing distribution centers. Then obviously the real powerful of modeling and using a tool to evaluate these types of decisions is to really go through a number of what-if scenarios to understand the various trade-offs of cost and service, to adding additional DCs to your network, shrinking your network, changing the flows, constraining the model to do certain things, letting the model choose in an unconstrained environment, almost like a clean sheet of paper. If you were to start all over, what would the supply chain look like? And again, using all of those outputs to evaluate what is the best solution for your business. And then lastly is obviously to plan for the future. Most of us are not interested in redesigning our supply chains for today's volume or yesterday's volume, but we're really trying to plan for the future, for growth, for anticipated changes in our business and strategy. And a tool and a model can help you evaluate the impact of the future if you stay in the status quo as you are versus what some alternatives could do for you from a cost and service performance perspective. So at this point it's probably apparent what sort of specific questions a network model can help you answer, but I'll run through these very quickly. So and we'll walk through the process here in just a minute, but the key questions that a network model can help you answer really is, what is the optimal number and the location of your distribution center? Should you have 1, 2, or 3? Should they be located in Memphis, Dallas, Los Angeles, Atlanta? The model can help you explore and quantify and identify that optimal number and locations. It can also help you quantify the role and the capacity and the size of each facility in the network that provides that optimal solution of cost and service. So you can use the model to test regional strategies, hub and spokes strategies, whether you should have inbound and outbound consolidation centers. Again, the model is a helpful tool to help you quantify that in real objective terms. The model can obviously help you evaluate network performance in terms of how it performs today versus all those various alternatives. It can help you plan for growth and see where you might need to make changes, where you might have capacity issues in the existing network, where you might need to make some investments in DCs moving forward. And then lastly, though, the model won't spit out an implementation plan for you by taking a very comprehensive view of iterative scenarios, and you'll gain perspective on what is the sequence of events that needs to happen to get you from where you are today to the desired state of the future. So let's talk a little bit about the process or methodology. We see this as 6 fundamental steps and really 3 primary chunks of work that are involved in building a network optimization model. Again, using a commercially available optimization software tool or package. The first step of the process on the left-hand side is really gathering the inputs and understanding the current state of the network. So identifying where DCs and customers are today, how product flows through the network, what are all the historical costs in terms of all of your logistics components, inbound, outbound, DC fixed and variable in inventory, collecting data around the demand, and then obviously again we want to plan for the future, so some sort of perspective on where the business is headed from a growth standpoint. We typically recommend there's some front-end analysis just to make sure that the data is clean and valid before you populate the software model. But once the model has been transformed, it's in a clean state for the model, then you'll take those transactional information that you typically have aggregated, transformed into the input format needed for the tool, run that through the optimization tool, and then the first step of the process is to validate your historical baseline. Make sure that the model accurately replicates what's happened in your supply chain in the past, because you don't want to make decisions or use that model to test alternatives if the model is not accurately representing your current state flows. That's the historical baseline model. The other types of baseline models that are typically run would be an optimized baseline. So at that point, the software sort of takes over, and the software then assigns the ideal or the lowest cost DC for a customer to be serviced from. Sometimes you'll see some efficiency gains just by letting the software optimize and reallocate, but that gives you what I'd call a perfect execution model, which is the model that you'll want to use going forward to compare alternatives. And then the other baseline that we normally build is what we call an adjusted or a modified baseline, and often there what we're doing is taking the baseline historical model, growing that into the future so that we can project 5, 6, 7, 10 years into the future based on our growth rates. What would it cost us to execute our distribution network in our current infrastructure? What would our service be, again, in that future state? Once the baselines have been built, validated, and locked in, the really fun part of the network modeling exercise begins, which is evaluating all the alternatives and the different scenarios. So the model can choose the optimal network by finding the lowest overall cost. You can constrain the model to find what is the best 1 DC, 2 DC, 3 DC, 4 DC network. You can use the model to constrain it by locking in certain facilities that you know you want to keep for various business reasons. Lock the model in with those particular facilities and then see what the incremental difference is versus your optimal or your other scenarios. You can constrain it with capacity. There's all types of ways that you can use the model to help you evaluate the differences in different network structures. And then the models will report out the key cost components around all the different costs, inbound, outbound, freight, DC fixed and variable costs, and inventory cost, and then typically report out service expressed in terms of distance or proximity to your customers or your demand and proximity to your suppliers. Just a little more detail around the input. So we've covered most of this, but the cost data that you'd be looking for to build the model, transportation cost is typically historically going to come out of a TMS system. You may keep it in your accounting system. P&L is also very helpful for getting your warehousing cost in terms of the fixed cost, the variable cost. What are you paying in rent? What are you paying in labor? Inventory carrying charges typically provided by finance, so that's around the cost side of it. And then in terms of transactional data that you'll want to collect, and we recommend collecting typically 12 months or a full business cycle so that you get a full view of the business, all the supplier locations and the volumes associated with them, customer locations and their respective demand, products and their various attributes around cube and weight and groupings, and then inventory levels, both at peak and average, so you understand what your capacity requirements will be from a inventory holding capacity. And then not a historical piece of information, but again, some sort of perspective on growth, whether that's just top line sales growth or product growth at a family level, some metrics that help you project what the requirements are moving into the future. Then on the output side, the things that you'll get out of the tool and out of a modeling exercise is obviously you'll get an optimal recommended network based on minimizing cost typically. And you'll get all of the outputs from a cost and financial perspective, from a volume perspective, what volumes were assigned to which DCs, what are the new service metrics, again, typically expressed in terms of mileage or distance. And again, software in and of itself will not produce an implementation plan for you, but the various alternatives will give you some perspective on how you would want to implement the desired network. So you can see in the upper right-hand side of this page is just sort of a typical view of a comparison of a baseline or a current DC network, what the total network cost is in the baseline, the volumes that are assigned to each one of those DCs, what percentage of the units are delivered within 1,000 miles, which was the metric for this particular project, and then you can see a snapshot of the some of the scenarios that we looked at in terms of a 6 DC and a 5 DC network and what the service metrics are, as well as the cost savings for those various options. So that's kind of the quick and dirty around the process, the methodology, and what distribution network modeling does from a value perspective and a principle perspective. I think it would probably be helpful to spend the rest of our time really focused on a couple of case studies which show how these principles were implemented for some real projects. So the first one was a retailer. They had a single DC that was servicing all of the United States, servicing about 900 stores when we first engaged. One of the challenges that they were facing is that existing single DC was operating at capacity, so they were having to use off-site storage and rental trailers, and then all the attendant cost of handling and moving product back and forth between those off-site facilities and trailers to the primary DC. They also had a lot of aging equipment from a material handling perspective. The buildings were aging as well and needed some investment dollars to keep them up and operational. They had some challenges with cycle time from the time they placed an order with a vendor or supplier till the time it arrived at the DC, was processed, and then shipped back out to the store. It was a fairly significant cycle time to do that with that single DC network as it was. They were planning to grow the business significantly over a 5-year period, planning to nearly double the business over a 5-year horizon. And then this is the study that I was referring to earlier, where they were looking to penetrate a new market where they really didn't have a lot of stores, but really wanted to grow that area, and that particular market or area was not in close proximity to the existing DC. So the fundamental question that they wanted to answer is much like the questions that I outlined in the overview: is, what should their optimal network look like in order to minimize their cost? They wanted to improve their service. They needed to support their future growth. They wanted to understand, should they continue to invest in that existing DC, or should they move, or should they add more DCs to the network? So we followed the process and the methodology, collected the historical data, built a baseline of historical performance, adjusted that baseline to project what the cost and service would look like in that 5-year planning horizon, optimized it, and then compared that to a number of different scenarios. So we went through what's the best single DC, 2 DC, 3 DC, 4 DC network, etc. and then ultimately landed on a 3 DC network was the best solution to meet their business requirements. Metrics suggested about a 20% reduction in logistics cost or cost per unit, fundamentally driven by significant reduction in transportation savings, both on the inbound and on the outbound side. Because we were getting closer to our customers and closer to our suppliers, the new network made a significant improvement in service, radically reducing our distance to our stores, our distance to our vendors, which reduced that overall cycle time from supplier through the DC to the store. Because we knew we were going to would have to make investments in the existing DC if they did nothing, we were able to compare the incremental capital of new buildings and a 3 DC network and really all the scenarios to that investment they would make if they stayed where they were at, and we saw really less than a 3-year payback on that incremental investment, so very favorable ROI. And then lastly, sort of a byproduct of this exercise was because we were operating at capacity in the existing DC, by spreading the volume across multiple DCs, it relieved some of the capacity issues at the current DC, allowed us to establish some best practices, some new operational procedures and flows in the new DCs, just to streamline our overall distribution operations. So that's the first one. The second one is also a retailer, a large retailer with about 17 fulfillment centers and service centers located across the United States, servicing around 2,000 stores. Basically, their service goal is to be within about 250 miles from the DC to the store for at least 80% of the demand. They operated their own trucks in a route stop delivery mode, and their fundamental questions that they wanted to answer were, number one, do they have the optimal network? And then what changes should be made to get them from where they are today to the optimal? And then also for this particular client, they really wanted to understand two sort of overarching scenarios. Number one, what would the network, or should the network, look like if their business is flat and they basically don't experience any growth in sales revenue or volume? Would it change? Would it stay the same? And then secondly, in a growth mode, with 3 to 5% annual growth over a 5-year period, does that change the answer? Does that point to a different solution for the network of the future? So again, follow the methodology, built a baseline, validated that baseline, and then ran a number of different scenarios, let the model pick the optimal, and then went through a number of constrained scenarios where we forced the model to pick the best 3, 6, 12 DCs and compare that back again to our optimized baseline. Basically what we found out for this particular client is that the 17 DCs that they had were fundamentally located in the right places. We did see, as we moved to that growth scenario, because of some capacity issues at some of the DCs, that adding an additional site in the future would help relieve some of that capacity, save us about $1 million a year at that point in time. Some increases or improvements in service, you can see from about 79.7 to 81.3, so fairly small, but again, some improvements there. One of the things that we really leveraged with this particular client was really just understand some existing buildings. Should they keep them open or should they close them? They had some leases that were coming up. I had some buildings that weren't ideal from a DC operations perspective, and really wanted to make sure that they were located in the right cities, had the right volumes. So we saw some shifting of volumes as we went through the modeling exercise and evaluated some alternatives, again, where we forced some of the DCs to remain open regardless of what the model wanted to choose. And then what we found at the end of the day was by reallocating some volumes, we were able to relieve some capacity from some buildings without fundamentally affecting service or cost. So that's the second one. And then the last one is an industrial parts distributor that we looked at. So context of their current state, they were operating in a single DC network up in the Northeast. That DC was operating above capacity, so they had outgrown it. Had some off-site locations, again, to offset some of those capacity deficiencies, moving product back and forth between a primary and those off-site DC, so inefficient operations. Planning to grow the business by about 40% in sales over a 5-year period. And then I think really the big issue with this particular client was around service. There were some competitive pressures in the marketplace to improve their service. By having a single DC in the Northeast, they were servicing about 35 to 40% of their customers within 2-day ground service, and they really wanted to be at 85%. They felt like that was the metric they needed to be at. So their question was, what does it cost us to get to that 85% 2-day ground coverage? How do we do that at the lowest possible cost? How do we build capacity into our network to account for that 40% growth over the 5-year period? So again, followed the process and methodology, validated our baseline model with the client, and the recommended solution that we landed on was about a 6 DC network. That allowed them to get not only 85%, but really allowed them to get to 95% of their dealer or customer locations within 2-day ground. Again, significant improvement over where they were today. The other thing that we were able to test and identify in the model was really just sort of the flow and the strategy of what each DC should do in the network. So we were able to identify that we wanted to keep the Northeast DC, it was located close to manufacturing, keep that distribution center, let it operate not only as a regional DC to service the Northeast, but also as the hub for slow-moving items, so it could restock the regional DCs. And then also by leveraging one of the other channels in the distribution network they had, we were able to share some of the savings or share some of the cost and use our dealers also to provide forward stocking locations for those faster moving SKUs and DCs. At the end of the day, the return on investment for moving from that single DC to the 6 DC network was a little less than a 3-year return on about a $7 million capital investment. So hopefully by going through the concept of distribution network optimization and modeling in particular, and then walking through those case studies, you can see the value of performing an exercise like this and see how you can improve your service, reduce your cost, really balance between cost and service, remain competitive, and at the end of the day, just improve your overall supply chain performance.
I want to thank Wayne for presenting this material. I'd also like to thank everyone who joined us today. We hope you found this information to be relevant and valuable to your organization. If you have any questions about network optimization, please email us at info, that's INFO, at associated-solutions.com. And thank you and have a great day.